Okay, this video is on our inverse trig functions, and these guys are a bit of a, oh, they're not too bad. I was going to say they're a pain, but they're not too bad. Inverse trig functions, okay? Not to be confused with reciprocal trig functions, okay? So just to point out what the difference is your, let's say we've got y equals sine x. The reciprocal function of that is y equals 1 over sine x, okay, which is cosec x. Now this is your reciprocal, which means 1 over, okay. And what we're doing today is our inverse of sine, okay. So you remember, if you've got some equation or something like sine x equals half, and then the way you solve that is you go, well, x is equal to sine negative 1 over half. But what does this sine to negative 1 actually mean? Well, that is your inverse function, okay. You're doing the inverse operation of sine. And it's interesting to note what people think, because if you typed in that into your calculator, sine negative 1 inverse sine of half, then hopefully you'd expect to get, or if it's in degrees, you'd say 30 degrees, or pi over 6 radians, okay? One of those two. But how is that right? Because let's just try it. I'm going to just pick a different value. Let's say 150, okay? What's the sine of 150? 150 degrees. Okay, you think about it. If you type this into your calculator, sine of 150 degrees equals a half. Holy crap, okay. So what's happening here? Try sine of 390 degrees. You'll get a half. There's all sorts of different solutions to this, not just x equals 30. So what is going on here? Why does your calculator only tell you that the inverse sine of a half is 30 degrees, or pi on 6, one of those two? What about all these other solutions here? Like, what is happening? And that's what this section is all about, is knowing how this function is defined. Okay, and so let's have a think about this. Our sine function, y equals sine x, looks like this. Beautiful drawing, okay, which is a many to one function, okay. So we can apply the function test to it. Anytime we do a straight line down, we only hit 1 point. So yes, that's a function, but it's actually many to one. If we draw a line across this way, we get many solutions across here, which means that if we take the inverse of this function, which is y sine negative 1x, then it's no longer a function, okay. So if we do the inverse of this, so let's have a look at what the inverse of this would be. X equals sine y, therefore y equals sine negative 1x. So you would have learned methods how to find the inverse functions. There we go. So the inverse function is that. What actually happens, you'll remember, to an inverse function is whenever you find that it actually gets flipped in the line y equals x. So if you've got this line y equals x on your axis here, then it just flips it all together. And so what you actually get is, let me try and draw it the best I can, actually goes like this. Okay, it goes up and down like this sort of thing. And so that is what y equals sine negative 1x looks like. But this is not a function. If you draw a vertical line test down here, you get many points. And so this is not a function. And it's very irritating because you get infinite solutions to this. And so what people have decided over the years is to just restrict the values for y here. And so in fact what they've done, okay, green, is they've said, well, we're only going to look at this little section here, and we're going to restrict it to those values. So this is the bit that we want in here. And what that ended up looking like, and we'll do it better in class, is a graph that looks like this. A graph like this, and it will be, it's just this section that goes like this, and it stops at pi on 2 up here, starts at negative pi on 2, and this value here is negative 1, and this value here is 1. And basically that is your inverse sine function, because we restrict the y values to negative pi on 2 to pi on 2. We're only going to give an answer in this range. So on the previous screen we talked about that it spat out an answer of 30 degrees or pi on 6. That's because that is the answer to this question, in this range here. And so that's where that comes from. So that there is your sine function. Inverse sine function. Isn't it a beautiful little thing? It starts at -1, negative pi on 2, and curls up and finishes at 1 pi on 2. Okay, so 1 pi on 2, and starts at -1, negative pi on 2. Beautiful. Goes through the origin, nice and easy. Okay, let's have a look at the cos. Again, if you look at y equals cos x, the graph of that looks like something like this, blah. Okay, again, if you turn it on its side, if you find the inverse function, then you get something like this, and I'll try my best. It'll go like that. It's hard to sort of imagine, but that's what it looks like if you flip it on its side. If you reflect it in the line y equals x, if you reflect it in that line, that's what you'll get. And again, we have, this is not a function. We have many one to many, which is no good. So what we do is we restrict it. And if you look at this, if we restrict it the same as we restrict sine, like if we restrict it from between there and there, which is negative pi 2 pi 2, can you see this is still not a function? Okay, so that's function. This is still not a function. And so what we do is we use a different range for this. In fact, we draw it between here and here. Maybe I should use a different color there. But we actually just draw it in that range there, okay? And that gives us a one-to-one function. What does that end up looking like? If I draw it, I should have got my graph out. I'm sorry about this, bit slack. But what we get is this function here. Okay, finishes there. That point is pi. That's pi on 2 there. I'll just write that on there. 2. That's 0. Here's the point -1, and there's the point 1. Okay, and so that's our function y equals cos -1x. We've restricted it to just into that range. Okay, excellent. Let's look at tan. Y equals tan x. Remember, it looks like all of your little wiggly worms, like that. And they all have these asymptotes down here, don't they? Okay, and they're at pi on 2. I'll just write pi on 2, negative pi on 2. Okay, so if we flip this on its edge again, what do we get? If we flip it on its side, we get one sort of going through the middle, and then the asymptotes have changed ways, and then we get blah 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 lines like this as well. Okay, and again, this is not a one-to-one function. Okay, so this is not a function. What do we need to do to it to make it a function? Well, all we do is we're going to restrict it to these values here. So that's what we're going to talk about there. So what our function ends up looking like is we're going to get asymptotes up here, down there. That's going to be at negative pi on 2. This will be at pi on 2, just like up here. And the function comes across as an asymptote, comes up at 45 degrees and goes through there. Well, it's not very good, but it's more curvy than that. But that is your tan function, inverse tan function there. Okay, so just in general, just to summarize that, we've got y equals sine -1x, y equals cos -1x, y equals tan -1x. So sine -1x looks like this. It has a domain. If you think about it, the domain goes from -1 up to 1, and the range goes from negative pi on 2 to pi on 2. That's our function there. Y equals cos x looks like this. It sort of starts there and goes up and across like that. and it has a domain exactly the same as sine as that, and it has a range, starts at 0 and goes up to pi, and y equals tan x looks like this, and goes up across like that. It has a domain of all of r, it's defined for all r, and its range is not inclusive of negative pi on 2 to pi on 2, not inclusive. So there are your 3 inverse functions. Next video we'll actually go through and do some little work with those.